James Webb Telescope have undermined the case for the Big Bang.
Telescope, ever launched into space, made another successful step on its journey to a point 1,000,000 miles away from Earth today.
The James Webb Space Telescope was built to observe the birth of stars and galaxies, to look back toward the very beginning of time. What it wasn't built for, what nobody expected, was to spot something that might rewrite not just the laws of astrophysics, but our place in the universe. Yet here we are. When Webb aimed its infrared eye at a previously unremarkable patch of sky, barely more than darkness, it returned images and data that scientists are still struggling to explain. At a distance of about 1,100 light-years, in a system with a stable star and a planet well within the habitable zone, something unusual was happening. Rhythmic pulses of light, geometric patterns, structured emission. This wasn't the chaotic glow of distant quasars. It wasn't the swirling mess of early galaxy formation. It looked deliberate. It looked like infrastructure. Let that settle in. From 7 trillion miles away, the universe may have just blinked back. These light formations weren't random. They pulsed in intervals, consistent, repeating, organized. Think about city lights viewed from orbit. You see streets, blocks, districts. Now take that visual, blur it through the haze of interstellar dust and cosmic interference, and imagine still being able to make out structure. That's what the Webb team saw. Not naturally emitted energy from stars, not ionized gas clouds, but concentrated points of light arranged in what can only be described as an intelligent grid. This immediately triggered a frenzy in scientific circles. Theories that were once brushed off as out there were suddenly being dusted off and reviewed. The idea of detecting alien life via light leakage isn't new. It's been discussed for decades, but it's always remained theoretical until now. Let's talk scale. At over 1,000 light-years away, that light began its journey toward us before the printing press was invented. That means if we're seeing artificial illumination now, it's a glimpse into the distant past of another world. Whatever sent those photons may no longer exist. Or maybe, just maybe, they've advanced even further. The more scientists studied the Webb data, the stranger things got. First, the patterns. The light wasn't just consistent. It followed a frequency curve that mimicked terrestrial power usage, rising and falling in cycles, like cities switching on and off over a planetary night. That fluctuation matched models used to track energy consumption in urban environments. From Earth, we've seen similar pulses in satellite imagery of our own nighttime glow. Second, the spectral data. When Webb examined the starlight filtered through the atmosphere of this exoplanet, it picked up traces of compounds we don't typically associate with natural processes. Nitrogen dioxide, sulfur dioxide, traces of chlorofluorocarbons, chemicals that, on Earth, are byproducts of industry. You don't get those just from volcanic activity or lightning storms. You get them when machines are running, when factories are active, when something is using the air. That's when the question stopped being about what is it and became who is it? Because even if this isn't proof of intelligent life in the way we imagine, with language, culture, or spaceflight, it's evidence of a planet undergoing change due to technology. And that, by any definition, is a technosphere, a biosphere altered by intelligence. Not everyone in the scientific community is ready to label this first contact. Many are urging caution, pointing out the risks of jumping to conclusions. And they're right. Extraordinary claims demand extraordinary evidence. But here's the thing. The evidence is mounting. Webb picked up thermal signatures that correlate with these light pulses. Meaning, some of those bright spots are also heat islands, which is exactly what you'd expect from places of high energy use, whether they're massive data centers or bustling megacities. Even more curious, electromagnetic noise. The kind of faint, background emissions you'd expect from an industrialized society. Webb's sensors detected patterns, not structured enough to be communication, but definitely too consistent to be random. Put it all together, artificial-looking light, thermal anomalies, industrial chemical traces, and persistent EM background. All centered on one rocky planet in a solar system eerily like our own. And maybe the most haunting part? It's been happening for over 1,000 years. Because remember, we're looking back in time. That light started traveling long before we invented electricity. We're seeing echoes of what was. That civilization, if it still exists, could be centuries ahead of us.
Or gone.
Obliterated by time, or war, or a cosmic accident. But if they're still there, if they're watching their skies the way we're watching ours, then maybe they'll notice us too. This isn't just a science story. It's a turning point. Because for decades, we've searched for signs of alien life in radio waves, waiting for a deliberate transmission, a hello from the dark. What Webb might have captured flips that script. Maybe we were never supposed to wait for a message. Maybe the message was the glow, the unintended leak, the light that spills out from a world at night when the workday ends and the city comes alive. What if that's the real beacon? And here's the kicker. If we can see them, someone else out there can see us. Our cities, our lights, our own fingerprint glowing faintly in the void. If they're out there, they already know we're here. The realization that light, structured, rhythmic, artificial light, can serve as proof of intelligent life reshapes how we explore. It shifts the entire SETI paradigm. Instead of focusing only on radio telescopes, future observatories may be designed to detect planetary light signatures, to map nighttime emissions across distant systems, and to catalog the accidental communication of energy use. Because that's what this likely is. Not a message to us. Just life, doing what life does, changing its environment. And in that change, revealing itself. And maybe that's the lesson here. That presence doesn't always come with intention. That contact doesn't have to start with a signal. Sometimes, it's just a glow on the edge of nothing. And just like that, the definition of contact may have changed forever. As the Webb data continued to stream in, the modeling teams went deeper. Using adaptive simulation and light distribution algorithms, they reconstructed potential city-scale layouts on that distant planet. It wasn't precise. Nothing at this scale could be, but the resulting models bore an uncanny resemblance to planetary urban clusters. Linear roads, centralized nodes, even potential megastructures spanning kilometers, suggested by persistent luminosity patterns in specific grid formations. These weren't just blobs of light. They had hierarchy,
Flow. Complexity.
the kind of things cities develop over time through planning, growth, and adaptation. Even the light decay followed fractal patterns consistent with human urban sprawl, the same way light diminishes from downtown cores to residential zones. It was an eerie parallel. And yet, this might only scratch the surface. Because Webb also detected oscillating spectral shifts not tied to light or temperature. These were subtle, almost imperceptible frequency modulations. They repeated. They varied. They obeyed no natural cadence. And while they couldn't be decoded into language or symbols, they looked deliberate. Not a message, but a trace. Something embedded in the medium. A beat. A rhythm. Like a heartbeat etched into the fabric of light. Some researchers speculated we were seeing byproducts of an advanced energy grid, power modulation across planetary infrastructure. Others whispered about communication systems too fast, too compressed, or too alien for our machines to even recognize. Whatever it wasn't noise. Then came the environmental readings. Webb had already confirmed the presence of nitrogen-based gases and unusual industrial compounds. But the deeper the analysis went, the stranger things became. There were readings that couldn't be attributed to known chemistry. Trace isotopes never before measured. Light absorption profiles inconsistent with any natural element cataloged in Earth systems. And then the curveball. A secondary planet, farther out in the same star system, showed a faint, artificial glimmer. Not nearly as strong, not consistent, but it was there. A flicker, a single point of infrared pulse echoing once every several weeks. A dim, repeating blink, like a lighthouse, pulsing across centuries. The team didn't know what to make of it. Was it another inhabited world? A satellite? A reflection from an orbital array? Or something else entirely? An outpost, a power station, an ancient warning left spinning in space? That blink, so simple, so lonely, might be the last functional artifact of something long gone or the first deliberate signal. Humanity, for the first time, was staring at a system that could have not one, but two engineered objects beaming signals into the cosmos. If this is confirmed, it would mean this civilization not only survived long enough to become visible, it expanded. That's no longer just a Kardashev Type 1 civilization. That's planetary system management. That's coordinated development on a scale we've never even come close to achieving. And yet, no contact. No direct response. No greeting. Just lights. Patterns. Silence. But maybe that silence isn't indifference. Maybe it's protocol. Maybe civilizations don't broadcast in obvious ways because they know the risks. Maybe we're supposed to watch and learn first. To see the lights, study their rhythm, and prepare before knocking on the door. Because here's what scares some scientists the most. The lights may have been brighter once. Stronger. More organized. And what we're seeing now could be the afterglow. The final breath of a society that peaked and then fell silent. And we're only now catching up to their last flicker of brilliance before the dark. The thought that we're seeing the funeral pyre of a once great world is haunting. But the opposite, that they're still there, watching, waiting, might be even more. So what now? Agencies across the globe have begun reorienting their infrared observatories toward the system. SETI is coordinating with data centers to scrape historical survey archives for any missed clues. Private space agencies are offering time on telescopes. Even planetary defense teams, typically focused on asteroids, are weighing in on the data. The next step may be building instruments specifically tuned to these kinds of signatures: light architecture analysis, thermal pattern decoding, atmospheric pollutant detection. Not to find more exoplanets, but to interpret their behavior. To build a lexicon of planetary intelligence. And behind the scenes, world governments are quietly talking. Not about invasion or panic, but about acknowledgement. What this moment means. How to prepare society. What to tell the public. And most importantly, how to responsibly handle the next breakthrough. Because there will be one. If not tomorrow, then next year. If not from this system, then from another. We've cracked the first layer of the cosmic shell, and there's no putting it back. The question isn't, are we alone? Anymore. It's how many are out there? And who noticed us first? This is the edge of the map, the point where the known world ends, and something else begins. Lights in the dark, too precise to ignore. Rhythms that aren't echoes, but signals. And a telescope not built to find aliens somehow may have done exactly that. If this video got you thinking, leave a like, hit that subscribe button, and drop your thoughts in the comments. Do you think we've seen signs of alien civilization? Or is there another explanation? Either way, we want to hear from you.
See you next time.